Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 7.3, double angle formulas. So when it comes to double angle formulas, guys, if you guys want to know the formulas, your teacher will probably give you a formula sheet, and these are the main formulas you need to know. So there's a double angle formula for sine, there's three double angle formulas for cos, and then there's one double angle formula for tangent. Okay, and we're going to be using these formulas in the same way we used the compound angle formulas in the previous lesson. We're going to be using the double angle formulas for this lesson. So same kind of concept. Let's rip through some questions. When we look at the first question, part A, we got to see which double angle formula does this represent. Now, by the looks of it, I can kind of tell that this has some similarity to this sine double angle formula. In fact, this directly looks like this. So we got to know and recognize what looks like what. And then we got to find the left side of the equation. So here, I know that the 5x is actually going to be my theta. So now I'm going to have sine 2 theta, which is equal to sine 2 times my 5x. And therefore, my answer is sine 10x. So it's really just identifying which double angle formula we're using. Okay, let's look at question D. Question D talks about, I can clearly tell it's a fraction and it's using tan. So we know for question D, it's going to be this guy. The question is, what is theta? If I look over here, I can tell this guy, my 4x, is what theta is. So it's going to be tan 2 theta, which is tan 2 times 4x, which we end up with tan 8x as our answer. So this is pretty straightforward. We're just figuring out which formula we're using, and from the formula, we're just finding what is theta by looking at the pattern, okay? Let's look at this one. This one looks a little bit tricky. So we got a square in here. So 2 cos squared theta over 2 minus 1. If I look over here, that corresponds to this guy, which is my cos double angle formula, so cos 2 theta double angle formula. And I know that this guy right here is my theta. So it's going to be cos 2 theta, which is cos 2 theta over 2, which ends up just being cos theta as my answer. So remember, we're just finding out which formula it is, finding out what theta is, and then plugging that into the equation. Mind you, the reason why it's cos theta is because obviously the 2's canceled out over here. Okay, let's look at question D. Cos squared pi over 12 minus sine squared pi over 12. That one looks like this guy. So we know it's going to be cos 2 theta, where my pi over 12 is my theta. So I'll have cos 2 pi over 12, which ends up being cos pi over 6. And cos pi over 6, well, we can actually solve for cos pi over 6 because we know the special triangle for it. Remember, special triangle for cos pi over 6, we have the pi over 3 here, the pi over 6, root 3, 2, 1. So cos pi over 6 would just be root 3 over 2. And that will be our answer. Now, for the previous questions like cos theta, because the theta is there, we don't know how to solve it, so we would just leave it as that. Same with the 10x and the 8x, we would just leave it like that. But in the case where they actually give us the value, so cos pi over 6, we can actually solve it through and through. Okay, let's go to the next one. Let's go to question E. So question E is right here. For question E, it's 1 minus 2 sine squared 3 pi over 8. So we know for this guy, we're going to be using this formula. So 1 minus 2 sine squared over 8. The sine squared 3 pi over 8 is equal to cos 2 theta. So it's going to be cos 2 theta, where theta we know is the 3 pi over 8. And then when we simplify this, we'll get cos 3 pi over 4. And we can leave our answer just like that. So the main purpose of these questions, guys, is to really just identify from the question which double angle formula are we talking about, and then finding theta. The main thing is we got to find theta. That's how we can solve for the left side of the equation once we find theta. Okay, I want to go through a little bit of a challenging problem. This is from the textbook. It's on page, I believe it's on page, let me just take a look. It's on page 408, 407, number 8, question 8. So in this question, they gave us an equation like this, and they asked us to solve for A. So you might get this kind of question as a thinking problem or an application problem. In the textbook, they labeled this as an application problem. So what we're going to do is we're going to solve this out. So the first thing I want to do when I solve this out is I'm going to say let t equal tan x. And I'm going to do this because it's going to make my life a whole lot easier. Okay? Now what I notice over here is with this tan 2x, we actually have a double angle formula for tan 2x, right? Tan 2x is has the double angle formula 2 tan x all over 1 minus tan squared x, right? So I'm going to rewrite this formula right here. So 2 tan x minus 2 tan x over 1 minus tan squared x plus 2a equals 1 minus, and then 2 tan x, tan 2x again, so 2 tan x over 1 minus tan squared x times tan squared x. So all I did was I just rewrote the question, and now what I'm going to do is I'm going to actually take this t and input it in as tan x every time in this question. So I end up with 2t minus 2t over 1 minus t squared plus 2a is equal to 1 minus 2t over 1 minus t squared times t squared. So we end up with something like this. So now that everything's in terms of t's instead of tans, I'm going to actually just simplify this equation a little bit more. So the 1 minus t squared, I'm actually going to take this guy and go 1 minus t squared. Whatever I do the bottom, I have to do the top because we're getting a common denominator. And in the same way, I'm going to do that over here as well. Whatever I do the top, I'm going to do the bottom. And then for this guy, I'm going to do this as well. Whatever I do the top, I'm going to do, whatever I do the bottom, I'm going to do the top. Okay, now let's clean this up a little. So the top over here is going to be 2t minus 2t cubed all over 1 minus t squared minus 2t over 1 minus t squared plus 2a minus 2at squared over 1 minus t squared is equal to 1 minus t squared over 1 minus t squared minus 2t cubed over 1 minus t squared. Cool. Now that I got this, because they're all under 1 minus t squared, I can really just cancel out all of these and just deal with the numerators. So let's actually rewrite it. So we'll get 2t minus 2t cubed minus 2t plus 2a minus 2at squared is equal to 1 minus t squared minus 2t cubed. And then from here, we can actually simplify it a little bit more. So because we have a negative 2t squared on 2t cubed on both sides, those will cancel out. The 2t and the negative 2t will also cancel out. And then on the left side here, if I factor out a 2a, I'll be left with 1 minus t squared is equal to 1 minus t squared. And then what I can do is I can say 2a is equal to 1 minus t squared over 1 minus t squared. 2a is equal to 1 because they cancel out, obviously. And then from here, we get a is equal to 1 over 2. And that's how we would solve this type of question. So notice how I use the double angle formula to get the whole formula written out right here. And then I use t equals tan x to make it simple. I don't want to deal with the tan x's because that's going to make my algebra a lot more tricky. But if I deal with just a variable like t, then it makes my algebra a lot easier. So these are like little tricks that you can do when it comes to applying your knowledge from the double angle formulas to make your life a little easier, because the rest is just algebra. So if you found this video helpful, guys, or you have other double angle questions, feel free to drop it in the comments. If you're somebody who needs tutoring, feel free to click the link in our description. Our team would love to help you out. But without further ado, I'll see you guys in the next video.